guys, hope that you're all doing well and that your families are all healthy and fine. Yesterday and the day before we started going over the final exam review. Today we're going to finish it. So what we've been going over and what's going to be on your final exam is everything we've done for Cycle 4, which is focusing on surface area and volume of three-dimensional figures. And just remember, surface area is always what's on the outside of a figure, volume is always what's on the inside of a figure. So the other day we worked with calculating surface area and volume of a prism, of a cone, of a sphere, and of a cylinder. The last one that we're going to cover today is going to be a pyramid. And I also saved it for last because it's the one that people usually have the most issues with. So I didn't want to combine it with anything else. I just wanted to leave it as is. You all know, again, for the most part, what a pyramid looks like. So you have a pyramid, right, where the faces are triangles. And then you have the bottom portion, the part that you don't see, and then the back part, right? So now, when you have a pyramid and you want to find the surface area and the volume, we'll start with the surface area first, right? The formula for surface area of a pyramid, what's on the outside of a figure, is capital B plus a half capital P times L. And what those represented again, B represented the area of the base, right? I'll write all that out. B represented the area of the base, right? P represented perimeter of the base, and the L represented the length of the pyramid. And it was those three things. And the easiest one to always deal with is L, right? Because how long the pyramid is, that's our L. But B, capital B, which is referred to it, B represents the area of the base, and P represents the area of the base. And these examples that I'm working with have been with rectangular pyramids because I didn't want to try to confuse you with other figures since we're not in class to explain everything. So whenever you're trying to calculate the area of a rectangle, it's always length times width. And whenever you're trying to find the perimeter of any figure, perimeter is always what's going around. So if we're talking about this base right here, right? If we're talking about just that base, perimeter would be how much is actually going around the base, right? So we want to find the area of that for B, and we want to find the perimeter around that for P, perimeter. So let's start with that. Let's say that we make this here. Let's say that this here were to be 6 feet. Okay? Let's say that the width would be 4 feet. And let's say that the length was 8 feet. So we have the length, which is always the easiest, right? We know that the length of the pyramid, how long this pyramid is 8. So we know that L equals 8, right? Then we want to find area of the base and we want to find perimeter of the base. We want to find those two. We want to find perimeter and we want to find the area of the base. So if it helps you, just label everything. We can make this the length, we can make this the width, right? If we want to find the area of the base, base is always length times width. And again, since we're talking about just the base, we want to deal with this 6 as the length and that 4 as the width, right? Here, in case some of you have issues seeing that number. So that was 6 feet. So that 6 and that 4 apply only to our base, which is the only two numbers that we're dealing with. To find the area of the base, since it's a rectangle, again, to find the area of a rectangle, it's always length times width. So in this case, since we're talking about the area of the base, we know that the length of the base is 6, right? We know that it's 6. We know that the width of the base is 4. So we would just do length times width. 6 times 4, and 6 times 4 is 24. So right there, we have that already as our base. We know that 6 times 4 is 24, so the area of the base is going to be 24. Because all I did was length times width. Again, we're only working with just the base for now. And 6 times 4 was 24. Now, to find the perimeter, this is where people have to be careful sometimes. When you're talking about finding the perimeter, all right? To find the perimeter, it's not just parts of it, it's always what's going around the entire base. So we know that this side here is 6. We know that that side is 4. And since we're talking about the entire perimeter, we can't forget about all the other sides that are going around. So if the front is 6, we know that the back is also 6 feet, right? If the right side is 4, we know that this left side here is 4 feet too, right? So we have that 6 there, we have this 4 here. So left and right are 4, top and bottom are 6. And whenever you're trying to find perimeter, you're just talking about what's going around on the outside, right? And with perimeter, you always add. So we're going to take 6, 4, 6, 4, and add them up. So we're going to do 6 plus 4 plus another 6 plus another 4, right? Because it's always all the sides that are going around the base. And the 4 sides are going around is 6 plus 4 plus 6 plus 4. And once you have that, all it is, it's just adding, right? You're going to add up those 4 numbers. So we know that 6 plus 4 is 10. 10 plus 6 is 16. 16 plus 4 is 20. So we know that the perimeter of the base is 20. And again, once you find those terms, the rest of the problem becomes so much easier. But just remember, whenever you want to find the area of the base, it's always length times width. So 6 times 4 was 24. Whenever we want to find the perimeter of the base, you add up all 4 sides. So 6 plus 4 plus 6 plus 4 gave us our 20. And always remember that the length represents the length of the pyramid, how long it is. And we know that the length of that pyramid was 8. Because now once you have these 3 numbers, right? Once you have all 3 of those terms, it becomes so much easier to actually do all this, right? Because now all it is, it's just substituting everything, right? So we look at our formula, and we're just going to substitute. We know that the area of the base is 24, right? Plus, we have the half. We know that the perimeter of the base, P, is 20. And we know that the length of the pyramid is 8. And that's all I did. I just substituted. Area of the base was 24 plus a half. Perimeter of the base was 20, which we figured out. And the length of the pyramid was 8, which we had there. And once you have all this, again, remember, before you add, you have to follow order of operations. And order of operations tells us that before you add, you have to multiply, right? So let's keep the 24, right? Let's keep the plus, keep the half, and let's just multiply. We know that 20 times 8 is 160. So all I did right now was just did 20 times 8, because order of operations tells us to multiply before anything else, and 20 times 8 is 160. And we brought everything else down, the half, the plus, and the 24. And again, before you add now, you still have to multiply. So what we're going to multiply is, we're going to do a half times 160. And there are 2 ways you can do that. You can think of what's a half of 160, or since it's a half, you can do 160 divided by 2, right? So we keep the 24, keep the plus, 24 plus. We know that a half of 160, or if you want to, we know that 160 divided by 2 equals 80. Right? We know that it's 80. So a half of 160 is 80. Think, half of $160 is going to give you $80. If you want to think of it that way, you could. If you want to do 160 divided by 2, it'll give you 80, just like we did there, right? Just to see it. Because now once you have that, all that's left is just the only operation there. It's telling us to do 24 plus 80, and 24 plus 80 is 104. Don't forget the units, feet. And since we're talking about surface area, it's going to be squared. Right? And so again, just follow along. Once we figured out all these measurements, we substituted them in. 24 plus a half. Perimeter was 20, length was 8. Before you add, you have to make sure you multiply. So 20 times 8 was 160. Before you add, you have to make sure you multiply again. A half of 60. You can do it that way. If you want to divide, 160 divided by 2 gives us 80. 80 plus 24 gives us 104 feet squared, which means that on this pyramid, there's 104 feet squared on the outside, because that's what surface area represents. The last question that's going to be on your final is going to end up dealing with volume of a pyramid. And it's a lot easier than this just to even look at. And the formula itself isn't as intimidating, but let me just go over that. So again, we have another rectangular pyramid, right? We have another rectangular pyramid right there. Triangles for faces, right? And then you have the bottom portion, the part that we don't see, which is why it's dotted, and then the back side, right? And now, whenever we're trying to find the volume of a pyramid, we have the formula, a third area of the base, that's why it's capital B, times the height. That's it. So it's going to be a third times the area of the base times height. So in order to find the area of the base, again, we need measurements. So it's going to be 4, let's do 4 meters. Let's say, let's switch it up, just so it's actually nicer to look at. That's 5 meters. This is 4 meters, just since it looks shorter, let's make it shorter. So that's for the base, and then we need a height, right? So the height is what's on the inside, and since a height is always straight, has to go straight up, we need a right angle. So let's make the height 6 meters, right? And that's all we need in order to find the area of the volume, In order to find the volume of that pyramid, we need to know what the area of the base is, and we need to know what the height is. The height's the easy part. The height there is 6, right? So we know that the height is 6. Now, in order to find the area of the base, it's exactly what we did before. In order to find the area of the base, since it's a rectangle, right? Since that's a rectangle right there, we know that the way you find the area of a rectangle is length times width. And in this case, we know that the 5 is the length, and we know that the 4 is the width. So all it is, just like we did before, we're going to do length times width, right, of the base. So the length is 5 times width is 4. That's all we have to do. And we know that length times width, 5 times 4 gives us 20. So we know that the area of the base here is 20. We know that the height is 6. And once we have those two measurements, now it becomes a lot easier to just do that. We know that the area of the base is 20. We know that the height is 6. So we can just substitute them in and simplify, right? We have the third. We know that the area of the base was 20 because we did 5 times 4 for the base. So area of the base was 20. And we know that the height of the pyramid was 6. That's all we did. We just substituted. A third, area of the base was 20, and the height was 6. So again, before you deal with the third, we can just multiply, or if you even wanted to multiply everything out, you could. But to make it easier to explain, before we deal with the third, let's multiply. We know that 20 times 6 is 120, so we have a third of 120. Okay? And that's all I did. I brought down the third. 20 times 6 is 120. And now our last step to this is take a third of 120. So some of you may think, again, what's a third of 120? And they can get their answers easily. Others may not be able to do that and actually want to calculate it. So if you see a third of 120, just think, when you see a third, it means just divide by 3. So if we're going to do that, we would do 120 divided by 3. And again, the reason we're doing 120 divided by 3 is it's a third of 120. When it's a third of 120, it means divide by 3. When we had the half before, 120, half of 120 would mean 120 divided by 2. But since it's 1/3 of 120, we're going to do 120 divided by 3, which gives us 40. And that's our answer. And the reason we got 40 again, if you're talking about a third of 120, it means 120 divided by 3, which gives us 40 meters. And since we're talking about volume, it's going to be cubed to the third power. And that's it. All the volume of that pyramid represents is that inside of this entire pyramid, you would have 40 meters to the third power, 40 meters cubed. Just remember, guys, again, you're going to have 12 questions on your final. You're going to have 2 that's going to be asking what surface area represents and what volume represents. And then you're going to have 5 different figures, all 3-dimensional shapes that we've worked with. It's going to be surface area and volume of a prism, of a cylinder, of a cone, of a sphere, and of a pyramid. So altogether, it's going to be 12 questions. Try your best, guys. Refer to this if you need to. Refer to the videos. Any help that you guys need, feel free to reach out to me. If you guys need to access the formulas, they're all on Pearson Realize under the formula sheet that I put there. Again, anything you need, guys, just feel free to reach out. Hope you all do well. Hope you guys are all doing well. Take care, guys. All the best.